Hello, and welcome once again to Backer Breaks It Down. In this episode, we continue to look at the long-run behavior of polynomial functions with a focus on intercept form. Because I know at the end of our previous episode, you were probably wondering, what about end behavior of polynomial functions if they're not in standard form? Okay, so at the end of our last episode, this was my summary. I was talking about the leading term test for polynomial functions. The leading term is the term that has the largest exponent. So when our polynomial functions are written in standard expanded form, it's really easy to determine what the leading term is. Like this polynomial here has a leading term of x cubed. I can easily see that. And the second polynomial, the leading term is negative x to the fourth. So when my polynomials are written in standard expanded form like this, it's really easy for me to identify what that leading term is. But the thing is like not all polynomial functions are going to be written in standard expanded form. Like we are going to encounter some that are written in factored form, like right now. Okay. So in this problem here, I have the function f of x equals negative 4x cubed times the quantity x minus 1 squared times the quantity x plus 5. So this polynomial function is in factored form, okay? I need to know the leading term so I can accurately describe the end behavior, okay? But I don't want to multiply this all out. Like that seems like an excessive amount of work to get one single term, okay? So I'm telling you that isn't necessary. You don't have to multiply this whole thing out, okay? We just have to think about the leading term of each factor. So like that first factor, negative 4x cubed, that's the leading term of that factor. The next factor, I have the quantity x minus 1 squared. So it has a leading term of x, and I do need to consider the exponent of 2. Because if I expanded x minus 1 squared, I'd get x squared something, okay? And then the third factor is x plus 5. It has a factor, or a leading term, I should say, of x, and then no outside exponent, okay? So remember what we did at the very beginning of this chapter. We found power functions. That's like what we're doing here is we are finding like a power function. We're finding that first term of our polynomial, okay? And we're going to do that by combining the first terms or the leading terms of like each factor. So we've got like the negative 4x cubed, right? And then we have the x squared. And then we have the x. So this is a product. And so you may recall from the very first lesson of this chapter when we multiplied things like this. So for negative 4x cubed times x squared times x, we added the exponents, right? And so I'd end up with negative 4x and then 3 plus 2 plus 1 is 6. So negative 4x to the 6th power is my leading term, okay? This is an even degree, and it's negative. The negative 4 makes it negative. So even negatives, this is their end behavior. So on the left and right, you have equal end behavior, and they're both negative infinity. So when polynomials are written in factored form, we need to think, what is the leading term of each factor? Okay, so looking at number 4, one of my leading terms of one of my factors is negative 0.25x. The next leading term would be x to the 3rd power, and the next leading term would be x to the 4th power. So if I put all those leading terms together, I have negative 0.25x times x cubed times x to the fourth. And if I actually do the math, my ultimate leading term will be negative 0.25 x to the 8th power. Because remember, we are adding all the exponents, 1 plus 3 plus 4. So once again, this is an even degree with a negative coefficient. And so both end behaviors would be negative infinity and negative infinity. So you could pause the video, try 5 and 6, check back in with me. So in number 5, the leading term of our first factor is negative 2x cubed. The leading term of our next factor is x. The leading term of our last factor is also x. So if I multiply all those leading terms together, I'm going negative 2x cubed times x times x. When I put that all together, I get negative 2x to the 5th. This is an odd degree polynomial with a negative coefficient, and odd negatives have the end behavior of positive infinity on the left and negative infinity on the right. In number 6, I'm going to identify the leading term of each factor. The first one is negative 0.5. The second one, be careful here. Look at the order of things. You have 1 minus x. X still has the larger degree. Don't ignore that negative. And then lastly, we have 2x squared. So we're going to use some other properties of exponents here to figure out what is the leading term. I need to multiply together negative 0.5, right, times negative x times 2x squared. Okay, and so you may recall for that 2x squared, I have to share the power. So I'm going to have negative 0.5 times negative x times 4x, because 2 squared is 4, and it'll be 4x squared because I'm sharing the power. So ultimately, when I multiply those three terms together, like the negative times the negative is a positive, and then 0.5 times 4 is 2, and then x times x squared is x cubed. So 2x cubed is my leading term. It's odd with a positive coefficient, and odd positives have an end behavior of negative infinity on the left and positive infinity on the right. So factored form can be a little tricky because it's not clearly obvious what the leading term is. Simply find the leading term of each factor, multiply those leading terms together, find the ultimate leading term. Classify it according to its degree and coefficient, match it to its end behavior. Okay, and that's how you apply the leading term test to polynomials written in factored form, and that's how Becker breaks it down.